The next chapter reveals the information of challenges in big data. So what are the characteristics issues with big data? Data volume. As data volume increases, the value of different data records will decrease in proportion to age, type, richness, and quantity among other vectors. The social networking site existing are themselves producing data in order of terabytes every day, and this amount of data is definitely difficult to be handled using the existing traditional systems. Another characteristic issue is data velocity. Our traditional systems are not capable enough on performing the analytics on the data, which is constantly in motion. E-commerce has rapidly increased the speed and richness of data used for different business transactions. For example, website clicks. Data velocity management is much more than a bandwidth issue. Another characteristic of big data is data variety and is again an issue. All this data is totally different, consisting of raw, structured, semi-structured, and even understand data which is difficult to be handled by the existing analytical system. For an analytical perspective, it is probably the biggest obstacle to effectively use large volumes of data. Incompatible data formats, non-aligned data structure, and inconsistent data cementing represent significant challenges that can lead to the analytics sprawl. Another is data value. As the data stored by different organizations is being used by them for data analytics, it will produce a kind of gap in between the business leader and the IT professional. The main concern of business leaders would be to adding value to their business and getting more and more profit, unlike the IT leaders would be concerned with the technicalities of the storage and the processing. Another characteristics issue is the data complexity. One current difficulty of big data is working when it is using relational database and desktop statistics visualization packages requiring massively parallel software running on tens, hundreds, or even thousands of servers. It is quite an understanding to link, match, cleanse, and transform data across systems from various resources. It is also necessary to connect and correlate relationships, hierarchies, and multiple data linkages or data can quickly spiral out of control. Another issue is of transport and the storage issues. The quantity of data has exploded each time, and we have invented a new storage medium. The difference about the most recent data explosion, mainly due to social media, is that there has been no new storage medium. Moreover, the data is being created by everyone and everything, not just by professionals such as scientists, journalists, or writers. Current disk technology limits are about 4 terabytes per disk, so 1 exabyte would require 25,000 disks. Even if an exabyte of data could be processed on a single computer system, it would be unable to directly attach the requested number of disks. Access to that data would overwhelm current communication networks. Assuming that 1 gigabyte per second network has an effective sustainable transfer rate of 80%, the sustainable bandwidth is about 100 megabytes. Thus, transferring an exabyte would take about 2800 hours, and if we assume that a sustained transfer can be maintained, it would take longer time to transmit the data from a collection or a storage point to a processing point than the time required to actually process it. To handle this issue, the data should be processed in place and transmit only the resulting information. In other words, bring the code to the data. Unlike the traditional method says, bring the data to the code. More challenges we have with the data management issues. Data management will perhaps the most difficult problem to address with the big data. Resolving issues of excess, utilization, updating, governance, and reference has proven to be major stumbling blocks. The sources of the data are varied by size, format, and by the method of collection. Individuals contribute digital data in mediums comfortable to them like documents, drawing, pictures, sound and video recordings, etc. With or without adequate metadata describing what, where, when, who, do and how it was collected and its provenance. Unlike the collection of data by manual methods where rigorous protocols are often followed in order to ensure accuracy and validity. Digital data collection is much more relaxed. Given the volume, it is impractical to validate every data item. New approaches to data qualification and validation are needed. The richness of digital data representation prohibits a personalized methodology for data collection. To summarize, there is no perfect big data management solution yet. This represents an important gap in the research literature on big data that needs to be filled. Another issue is processing issue. Assume that an exabyte of data needs to be processed in its entirety. For simplicity, assume that data is chunked into blocks of 8 words, so 1 exabyte is equal to 1k petabytes. Assuming a processor expands 100 instructions on a block at 5 GHz, the time required for end-to-end processing would be 20 nanoseconds. And to process 1k petabytes would require a total end-to-end processing time of roughly 635 years. The effective processing of exabyte of data will require extensive parallel processing and a new analytical algorithm in order to provide timely and actionable information. So what are the challenges with big data? In the previous slides, we have learned about the issues with the big data. So what are the challenges with it? The challenges in big data were usually the real implementation hurdles which require immediate attention. Any implementation without handling these challenges may lead to the failure of the technology implementation and some unpleasant results. Privacy and security. It is the most important challenge with the big data, which is sensitive and includes conceptual, technical as well as legal significance. The personal information of a person, when combined with the external large data set, leads to the inference of new facts about the person, and it's possible that these kinds of facts about the person are secretive, and the person might not want data owner to know any person to know about them. Information regarding the people is collected and used in order to add value to the business of organization. This is done by creating insights in their lives which they are unaware of. Another important consequence arising would be social stratification, where a literate person would be taking advantage of big data predictive analysis, and on the other hand, underprivileged will be easily identified and treated worse. Big data used by law enforcement will increase the chances of certain tagged people to suffer from adverse consequences without the ability to fight back or even having the knowledge that they are being discriminated. Data access and sharing of information. If the data in the company's information system is used to make the accurate decision in time, it becomes necessary that it should be available in accurate, complete and timely manner. This makes the data management and governance process a bit complex, adding the necessity to make data open and make it available to the government agencies in standardized manner with standardized APIs, metadata and formats, thus leading to better decision making, business intelligence and productivity improvements. Expecting sharing of data between companies is awkward because of the need to get an edges business. Sharing data about their clients and operation threatens a culture of security and competitiveness. Another challenge is the analytical challenge. The main challenging questions are as, what if the volume gets so large and varied and it is known how to deal with it? Another challenge is the analytical challenge, and the main challenging questions are, what if data volume gets so large and varied and it is not known how to deal with it? Does all data need to be stored? Does all data need to be analyzed? How to find out which data points are really important? And how can the data be used to the best advantage? Big data brings along with it some huge analytical challenges. The type of analysis to be done on this huge amount of data, which can be unstructured, semi-structured or structured, requires a large number of advanced skills. Moreover, the type of analysis which is needed to be done on the data depends highly on the results to be obtained, that is, the decision making. This can be done by using one of two techniques. Either incorporate massive data volumes in analysis or determine upfront which big data is relevant. Another section is of human resource and the manpower. Since big data is at its youth and an emerging technology, so it needs to attract organization and youth with diverse new skill set. These skills should not be limited to technical ones, but also should extend to research, analytical, interperceptive and creative ones. These skills need to be developed in individuals, hence require screening programs to be held by organization. Moreover, the universities need to be introduced curriculum on the big data to produce skilled employees in the expertise. Another set of challenges we have is the technical challenges. Fault tolerance. With the incoming of new technologies like cloud computing and big data, it is always intended that whether the failure occurs, the damage done should be within acceptable threshold rather than beginning the whole task from the scratch. Fault tolerant computing is extremely hard involving intricate algorithms. It is simply not possible to design absolutely foolproof, 100% reliable fault tolerant machines or software. Thus, the main task is to reduce the probability of failure to an acceptable level. Unfortunately, the more we strive to reduce this probability, the higher the cost. Scalability. The scalability issue of big data has led towards cloud computing, which now aggregates multiple disparate workloads with varying performance goals into very large clusters. This requires a very high level of sharing of resources, which is quite expensive and also brings with it various challenges like how to run and execute various jobs so that we can meet the goal of each workload cost effectively. It also requires dealing with the system failures in an efficient manner, which occurs more frequently if operating on large clusters. These factors combined put the concern on how much to express programs, even complex machine learning tasks. There has been a huge shift in the technologies being used. Hard disk drives are being replaced by the solid state drives. Phase change technology, which is not having the same performance between sequential and the random data transfer. Thus, what kind of storage devices are used is again a big question for data storage. Quality of data. Collection of huge amount of data and its storage comes at a cost. More data, if used for decision making or for predictive analysis in business, will definitely lead to better results. Business leaders will always want more and more data storage, whereas the IT leaders will take all the technical aspects in mind before storing all the data. Big data basically focuses on quality of data storage rather than having very large irrelevant data so that the better results and conclusions can be drawn. This further leads to various questions like how it can be ensured that which data is relevant and how much would be enough for decision making and whether the stored data is accurate or not to draw conclusions from it. Heterogeneous data. Unstructured data represents almost every kind of data being produced like social media interactions, to recorded meetings, to handling of PDF documents, fax transfer, to email and many more. Working with unstructured data is cumbersome and is of course costly too. Converting all this unstructured data into structured is also not possible. Structured data is always organized in highly mechanized and manageable way. It shows a well integration with the database, but unstructured data is completely raw and unorganized. So to conclude here, big data is all about the better analytics. So this is the end of the chapter 2, and now it's time to move on to the next, that is big data analytics platforms.